Okay, here we go. So we talked about square roots yesterday. Today we're going to talk about cube roots. But tomorrow we're not going to talk about fourth roots. We're not going to talk about fifth roots or anything like that. And the reason why is because once you see a square root, all of the other even-powered roots are very similar in shape, right? So a fourth root looks pretty similar to a square root. A sixth root, also an eighth, a 10th, a 12th root. They all look very similar to square roots, right? They're just a little bit more like flat, I guess I'll say. Cube root, same idea. Once you see one cube root, then all of the odd-powered roots, so the fifth root, seventh root, ninth root, so on and so forth, they all look pretty similar too. Okay, so that's why we don't really focus on any other roots besides square and cubes. What? I said odd-powered roots. They look all the same. All right. So anyway, graph the parent function for the cube root. So there's our cube root. Okay, we want to graph our parent function right here. Sorry, it looks like a little funky graph there anyway. So let's go ahead and plug these values in and see what we get. Okay, so we can go to our calculator here, okay, to help us out. We don't need it, but we'll use it just so I can show you guys. Now, how do you do a cube root? Well, you got to press the math button to do a cube root. So press math, and then you'll see the cube root command for my calculator is number 4. Okay, so math button, and then there's the cube root command. All right? And of course, we want to find the cube root of -8, which is -2. Okay. So in other words, -2 times -2 times -2 gives us -8. So the cube root of -8 would be -2. Are we allowed to take the square root of negative numbers? No, we get imaginary numbers, right? But we can take the cube root of negative numbers. Okay? What's the cube root of -1 going to be? -1, yeah, I'll show you here too. Okay, -1. Okay, what's the cube root of 0? 0, right? This 0 times 0 times 0 is 0. Okay, what's the cube root of +1? +1. What's the cube root of +8? 2. Okay, so you can see some symmetry here. Okay, some symmetry potentially. Let's plot these points then. So -8, -2. So, yeah, you might want to just count from the origin here. 1, 2. I agree. It's hard to see too. Okay, so right there, -2, -8. Okay, -1, -1. 0, 0. 1, 1. And then 8, 2. Okay, and we'll connect the dots. Okay, this is a cubic function that's just kind of like, well, reflector over line y equals x. Okay, it's like over a reflection. There it is. Okay, what is the domain of this function? -∞ to infinity. So we're back to our all real numbers there for the domain. What's the range of this function going to be? What's the bottommost y value? -∞. Yeah, we're going to keep going down there. So -∞. And what's the highest y value we're going to get to? +∞. Okay. Okay. I am not sure what to put in the blank there, okay? But it is like a snake shape. Okay, it is like a snake shape there, I guess you might want to call that if you like. Okay. It is the snake shape, okay? Based on your knowledge of transformations, describe the roles A, H, and K play for the family of functions y equals a times the cube root of x minus h plus k. In other words, what do H and K, A, H, and K do, right? So what do we know A does? What can A do to our function? Stretch. Okay, what are you going to say, Jackson? Are you going to say that too, Jackson? Okay, so if A is greater than 1, okay, we will stretch vertically by A. Okay, what if A is between 0 and 1? It won't stretch, it'll be a, instead of a stretch, a shrink. Exactly right, a shrink. Okay, So between 0 and 1, we will shrink vertically, okay, by A. And what if A is negative? It won't fit. What if A is negative? Now it goes down. Well, I see what you're saying. It goes down. Maybe. Can you? No, it'll still stay horizontal, but it's a reflection over the x-axis. And so if A is less than 0, reflect over x-axis. Ooh, I can barely fit it there. That doesn't even really fit. Put me on. Sorry, guys. Okay. What does the h do? The number that's in with the x. What does h do? I'll make this one shorter. What does h do?
Up or down?
No, it's in with the x. Left and right. That's right. Because it's in with the x, right, it shifts things left and right. Shift things left or right. I'm just going to make it easy for us here. Shift left or right. Right? And it still does the opposite of what you'd expect it to do. Right? So if it's x minus h, you're going to go right h. If it's x plus h, you're going to go left h. Okay? What about k? What does k do? Up, down. You got it. Exactly right. Okay? Shift up slash down. Okay? All right. So that makes h comma k the turning point here. So if you look at the snake, right? Look at the snake there. The origin is the normal turning point, okay, where the snake kind of like curves there, okay? The origin. And so we're going to be shifting, again, that point at the origin. We're going to shift that point at the origin, left, right, up, and down, and stuff like that to identify, or to, to help us graph and things. Okay, so let's look at our graphs right here, or our functions, and identify the transformations, right? So what is this? What's the transformation right here for this one? X minus 3, cube root of x minus 3. It's in with the x. We're going to go so left or right, exactly right. And since it's a minus 3, we're going to go right. Right 3. Okay? How about this one right here? We got an x plus 4. A plus 4 in with the x. That means we're going to go 4 to the left. So left 4. Okay? How about letter C? What kind of transformations do we see here? It's negative, so that means we're going to not shrink. Nope. We're going to reflect over the x-axis. That's the negative part. And then because it's 3, we're going to stretch by 3. Okay, stretch vertically by 3.
When do you shrink it?
Shrink it if it was like 1/3 or 1/2, right? Makes sense because it's going to be a fraction, right? Or well, a fraction that's less than 1, between 0 and 1. Okay, and then how about cube root of x plus 5? What's that plus 5 going to do? Careful, it's outside the cube root. So what's that plus 5 on the outside going to do? Up 5. Yeah, shift it up 5. Okay. Sorry? You're good? Okay. All right, so those are our transformations. All right, turn your paper over. We got one more transformation to look at here. Oh, there's all sorts of stuff going on here. Okay. What's the 3 in front going to do? Stretch by 3. Okay, what about the x minus 2? What's that going to do? Right 2. And then plus 7 to the outside, up 7. Very good. Okay. All right, let's take a look at number 5. Okay, 5 asks us to actually graph these things. Actually graph them. Okay. So, right, are we shifted left or right at all here? You guys see that, right? We're not shifted left or right, or we're not shifted up or down. So our turning point, TP, that's like our starting point here. It's still going to be at 0, 0. Okay? Whereas, let's look at letter B, do that one here too real quick. The turning point here, how is that going to be shifted?
By 3.
So 3 is going to be the stretch. But yeah, the plus 5 means we're going to go left 5. So instead of our turning point being at 0, 0, we're going to go left 5. So careful, left is the x coordinate, so it'll be negative 5 and then 0 if we're going left 5. Okay?
Yeah, but I have a question. So with the first one, isn't there a negative sign in front of it?
Yeah, we'll deal with that in a second. That's a reflection, but 0, 0 will still stay 0, 0 though. We'll still have that turning point at 0, 0. And the thing here, turning point here will be negative 5, so count left 1, 2, 3, 4, 5. There's that point. Okay? Oh man, that's hard to see. Gotta make it like really big. Okay, so let's continue with this one though. Back to this one here. Okay, so we're not shifted left or right, up or down at all. So we can go ahead and reuse those same. We can reuse those same perfect cubes that we know. So negative 8, negative 1, 0, 1, and 8. Whoops, went right through the 0 there. Okay. So if I plug in, man, that is too bad that I did that. If I plug in negative 8, what we said the cube root of negative 8 was? What's the cube root of negative 8? Negative 2, but then there's a negative in front. So what's a negative negative 2? Positive 2. Let's plug in negative 1. What's the cube root of negative 1? It's negative 1, but then negative negative 1 becomes positive 1. Yeah, plug in 0. What's the cube root of 0? 0. Negative 0 is still 0. Okay, plug in 1. What's the cube root of 1? 1, but it's negative 1, though, with the negative in front. And then 8 would be a negative 2. Okay, plot all these points here. Negative 8, positive 2 now. Negative 1, positive 1. And then 1, negative 1. And then 8, negative 2. Exactly, there's the flip. Exactly right. Some of you might be able to just flip it without having to do that whole table of values thing. And that's okay if you can do that accurately. So did we flip it? Yes, we did flip it. Did it stretch at all? No. I just did check in an X there. You know, yeah, that's all we're doing. All right, let's go over to letter B. Question? Grayson, you said wait. Oh, you just wanted to finish writing stuff? Yeah. I got you.
I'm good.
All right. Anyone else still writing here? I don't want to move on too fast. Is that a yes, Eric? Do you need me to wait, or are you okay?
I got it.
Okay. Yeah, we're going to letter B. Sorry, we're going over to. Wow, there's letter D here. I don't know where this D.
Go to letter D.
Sorry, yeah, sorry. We're going to the right one here. Okay. So now for this one, okay, we shifted. We did shift here, right? We shifted left 5. So I can't use the negative 8, negative 1, 0, 1, and 8. I have to shift all of these x coordinates left 5. Okay, so what's left 5 from negative 8? Well, it's going to be negative 13. And left 5 from negative 1 will be negative 6. Left 5 from 0 is negative 5. Left 5 from 1 is negative 4. And then left 5 from 8 is going to be 3. Oops, I'm kind of squeezing into my other graph. Yeah, so we do have a stretch of 3. That kind of worked out, didn't it? There we go. We'll do something like that. Okay, so the stretch is a stretch of 3. You're right, because there's a 3 in front. Is there going to be a flip in this graph? Do we expect a flip? No, it's a positive 3 in front, so you can put an X there if you want to. Okay, let's get these matching Y values, though. So negative 13 plus 5, negative 8. Cube root of negative 8, negative 2 times 3, negative 6. So negative 13, negative 6. Plug in negative 6, plus 5 is negative 1. Cube root of negative 1 is negative 1, times 3 is negative 3. Okay. Plug in negative 5. Negative 5 plus 5 is 0. Cube root of 0 is 0 times 3 is still 0. Okay. Negative 4, plug in it. Negative 4 plus 5 is 1. Cube root of 1 is 1 times 3 is 3. And plug in 3. 3 plus 5 is 8. Cube root of 8 is 2. 2 times 3 is 6. Now we'll plot all the points we can. I can't plot negative 13, negative 6. It just won't fit. But I can plot negative 6, negative 3, though. Okay, negative 5, 0 is already plotted. Negative 4, 1, 2, 3 is also already plotted. And then 3, 6 as well. 3, and then 1, 2, 3, 4, 5, 6. Okay. And I don't think, yeah, can you see that stretch there? It's pretty intense. What was your question there? Like, do you want to just like use your graphing calculator to help you do it?
No, I was just.
If you just did it mentally, that's fine too. Yeah, you don't have to make a table. Yeah, rated.
On the table, how do you figure out the x?
The x value. So in letter A, Braden, I chose the perfect cubes that we know. Okay, the same ones we used on the front there: negative 8, negative 1, 0, 1, and 8. So far, so good. They came from the front. It's just like yesterday we used the perfect squares: 0, 1, 4, 9, 16. Remember, those were perfect squares. And here we're using perfect cubes. So far, so good. Now, how did I get these x values? Well, because my graph here, Braden, right, it's shifting. And specifically, it's shifting left. That's going to affect my x values, right? Shifting left and right, that changes my x values up. You see what I'm saying?
Yeah.
So far, so good. So then negative 8, I shifted that left 5. Well, sorry, left 5 for you, okay? So if I'm at negative 8, I go left 5. I'm now at negative 13. And I did negative 1, shifted left 5, which is really just subtracting 5. Negative 6, and then 0 minus 5 is negative 5. 1 minus 5 gives me negative 4, and then 8 minus 5 gives me the 3. So that's where those x values come from, shifting them left or right based on the transformation we see right here. All right, so let me show you one more here. We'll do letter C, okay, and then we'll call it a day here. Actually, that one's not shifted left or right at all. Let's go to this one right down here. Sorry. This one has a left and right shift. Okay? So in this case, Braden, right, for the bottom left one here, okay, so again, folks, we're on the bottom left one of the worksheet here. For this bottom left one here, Braden, how are we shifted in this case? Okay, 2 to the plus 2 means we're going to shift. Yeah, to the left 2. And then the plus 5 means we're going to shift up 5. Left 2, up 5. Very good. Yeah, just like those absolute value stuff you were talking about today with Luke, okay? It's just like that. So negative 2, 5 will be our new turning point. Okay, and so when I make my table here, Braden, since I'm going left 2, I need to adjust all these x values right here from my other table. I need to make them go left 2. So left 2 from negative 8, negative 10. Left 2 from negative 1, negative 3. Left 2 from 0, negative 2. Left 2 from 1, negative 1. And left 2 from 8 is 6. Okay, Braden, just like that. And then I'll just plug those into the function one at a time, or the equation there one at a time, and get the matching y value. So negative 10 plus 2 is 8. Cube root of 8 is 2. Plus 5 is 7. Negative 3 plus 2 is negative 1. Cube root is negative 1. Plus 5 will be 4. Negative 2 plus 2 is 0. Cube root is 0. Plus 5 is 5. Negative 1 plus 2 is 1. Cube root of 1 is 6. And then 6 plus 2 is 8. Cube root is 2. Plus 5 is 7. Wow, I think I made a mistake here. Hang on. Yeah, I did, but I think I made a mistake now. Blah, blah, blah. Negative 1 plus 2 is 1. Cube root of 1, that should be 6, yes. Negative 10 plus 2 is negative 8. Cube root, oh, it should be 2. I said 2 there. Right? Oh boy, I'm really confusing myself here. No. All right, I have to cheat. All right, so negative 10 should be 3. I can't do math. Oh, forgive me there, folks. Negative 10 is 3. Negative 3 is 4. Negative 2, 5. Negative 1, 6. And then 6, 7. There we go. And you'll plot the points. Is there a flip here? Shh. Is there a flip here? No. Is there a stretch? No. Okay, you plot the points. I want you to finish this back for homework. Okay, finish for homework, please. The rest. Well, I guess, yeah. Don't miss that one right there, okay, for there. Finish the back, please, from that paper. Thank you. Thank you. Finish the back, please, for homework. Thank you, Sky. We'll go over this some more tomorrow, too, okay? We'll have time tomorrow. Thank you, you too, Grayson.